นี่มีตัวแล้วมีตัวแล้ว Hacking. Yeah.
Yeah. You start off with this one.
Let me do this. Yeah, I can do this.
Because I want to make sure the force is, because everyone is telling different things with the force, like they think there's two different forces.
Yeah.
So would we find force like this? Of one and then another one like that? Because that's what the book said.
In this case, both doesn't have the same elongation.
Yeah. Wait, they have the same elongation, not the same stress?
No.
Wait, they have the same strength, but not the same elongation. The book said the force would be different.
Yeah, the force would be different.
Yeah, so you have to find that, don't you? So
I'll do it.
Yeah. Yeah, sorry. So I know that. Still a little closer than I do. Those two. Win the problem.
So this is the first question on the previous sample. The professor took it down. I'm just going to go through this question. Here's the question. There is a bar with the outer part and an inner part. And there is material 1 for this one and material 2 for the outer part. So since two of them are stick together, so we can say the elongation of ever got this one?
Wait, why are you?
Yeah, see that's not what the book said.
That's not what the book says.
First.
I don't know the book said.
I got it.
Because the book said
The book says they.
the force is going to be different.
Yeah.
That's why they can't be equal to each other.
The force is going to be different.
The thing is, how is the information equal when we have two inner? We have an inner area.
Yeah.
Scales.
Yeah.
So
if you put it from both sides, it's going to be torque to the question both sides. Yeah, but the material inside is not going to be.
yeah, let's say
Oh yeah, you know why? Because what you have to write down is the deformation minus the deformation equals 0, right?
no, because they got a same deformation.
Okay, well, actually, can you keep doing this paper? We'll get it.
Yeah, I think you'll get
Let's
it.
just keep, you can do it here.
Correct. Because they are stick together, so how much you pull this? Even though the force won't pull this, because they are stick together, that's how it works. Like they are going to be pulled the same way. So you can write it. You can write an equation F1 L1 over A1 U1. This is the equation for the deformation. Yeah, so I can write it this way. The robot here is this, and you can choose one. And because the question gave us that there is a force, which is the total force of F1 times F2, in this case, which is equal to 10,000 pounds.
Wait, what does it equal 10,000 pounds?
Given in the question, right?
This is a thing from the future.
Oh, okay. It's like you cut a section in the middle. One force was 10,000.
This is so you did
There's a reactive force. I think two. So the addition of these two forces is going to equal 10,000. Okay.
Yeah. You cannot use that area to find like how much force you react on here and how much force you react here because we couldn't do that. We have to. The only thing we know that the total force on that area is equal to 10,000 pounds. That's why we can write. Let's say this is F1 and this is F1, that's F2 and F1. The total force on here is going to be 10,000 pounds. That's what the question gave us. So we can write out F1 plus F2 is equal to 10,000 pounds.
Are people going to have both that up?
No, some is going to be 10,000 pounds. They are not going to be equal. I mean, F1 is not going to be 10,000 and F2. You don't know how much is F1 and F2 now. You have to calculate it. Yeah. This is, yeah. So at E1 and E2 is given the problem. So we got E1 and E2 small. L1 and L2 is the same. Because they are the same part. And A1 and A2 calculate here. A1 is 2 times 2. That says A2. A2 is 2 times 2 minus the inner part, which is 1 times 1. And A1 is equal to just 1 times 1.
Do we have the L's?
Yeah, the L is given 40. Yeah.
Oh, do you say cross them off?
Yeah, because you can put it down and it's going to be close up because the Y L2 is and you can plug in A1 and A2, so you can get a relation between F1 and F2. And so there will be 2 equations, 2 unknowns, so you can solve for F1 and F2.
So F1 is F1.
Because
F1 over A1 P1.
Yeah.
We have that.
Yeah.
F1 over something over a value equals F over a value.
yeah,
And then put it in the form of one another.
because some will do it this way, but when the question gave us is 10,000 pounds, they try to divide the force by calculating an area. You cannot do it this way. you know how much force is going to act on part 1 and how much force is going to act on part 2. The only thing you know is the total force act on this part is going to be 10,000 pounds. Yeah.
So after you find the two forces, then just put it divided by the area, or no?
And you want to find the stress?
Yeah.
Yeah, you just divide by 3.
Okay.
Yeah.
And then for the elongation, you just give the modulus.
Yeah, just use the FL over AD and get it.
Okay.
Yeah. The main thing is you have to find F1 and F2, then you can do whatever you want.
So if there's another equation that is like the strain times
Oh, yes.
stress.
It's the same thing.
So we can use that, right?
Yeah, you can use that too. This one is stress is equal to strain times. Yeah, it's the
Yeah,
same.
and then we can find the strain and then multiply the strain by times the total length.
Yeah.
Right?
You mean to find the deformation?
Yeah.
Yeah, you're right. It's the same as using the
But it'd be
deformation.
the total stress. Because you find the elongation for each one, add them together, times the total length, you use total elongation.
You want to find the total elongation?
That's what it's asking.
Because the
This
elongation.
is the elongation of the bar. So that's the whole thing.
Okay, that's it. If you want to find the elongation of the part, which is the whole part, you can use either one because it's going to be the same. Let's say this part, the part 1 is going to elongate for 2 cm, the part 2 will do the same too. So you can use either part, you'll get the same answer.
Okay.
Yeah, that's how we started.
Fine.
Right.
Okay, just like
So,
yeah.
One.
Yeah.
So then we don't need to do
Yeah.
this section.
yeah.
Yeah, I know.
Yeah, I believe it.
Yeah. I mean, this is right about this.
I'll go to chapter 6 now and get okay.
Yeah.
Yeah. So we don't even need that one.
You need that because you got it. You are known.
But I thought we could just sell for FLAE.
Yeah, the deformation is
Oh, stress, total. And then the stress. The stress is just you do it differently, right?
Yeah. So F over A.
F over A, one of the outside material, one of the inside material. The only thing that's changing outside material is 3 inches because it's everything in 4 minus 1.
Oh, you mean here?
Yeah.
Yeah.
And the yellow is 1.
Yeah. So I'm going to torsion now. Okay. So let's revise the equation for torsion. There's a shaft here, and if I gave it a torque, double arrow is a torque, one arrow is a force. So don't get confused. And when you're given a torque, usually it will ask you for the fixed angle, which is over the and shear stress. Okay, so the T here is the torque, and the L is the lag. J of a circle is equal to pi r over 2. Or you can write it as pi c4 over 32. It's the same thing. Okay. And G is shear modulus. It's usually given in a question. This is the fixed angle. And this is the shear stress. Shear stress, this T is torque, C is the radius. So, and J is this one. So let's say if there is a torque here and it is asking you for, okay, let's see. This is a circle. So at which point shear stress is bigger? 0.1 or 0.2? This circle is a circle. 0.2. Anyone? Everyone know this? 0.1 or 0.2, which point has the bigger shear stress? If I gave you the torque. 0.2. Everyone know this, right? Because you look at the equation, shear stress is equal to TC over J. So the bigger the radius is, and here 0.1 the radius is this one. 0.2 the radius is the outer radius. So the bigger the radius, the bigger the shear stress is. Okay. The angle of twist. The angle of twist is always largest at here because the whole L is the length. If you are looking for the angle of twist at here, this will be the L. So the larger the L, the larger the angle of twist. Okay. So let's say if the question gives you the shear strain at the surface of here, you can use this. So if the question gave you the shear strain at here,
Is that the radius shear stress is also?
yeah.
And the question the radius is top. So divided by G. And J equation, the radius is
No, the J is always to be the same no matter which point I'm using. Because the J we are talking about a full bar. So the J you are always using, the R is going to be the maximum R. If it's a solid shaft. If it's a hollow cylinder, you will use You mean for the J?
yeah.
Yeah, the J you just need to, this is the outer circle and this is the inner circle. Yeah. So if it's a solid shaft, you just need to write ID for 4 over by 22. If it's a shaft with a hole, you need to include the inner diameter here. Okay. So we'll go through this again later. So let's go back to the question. If the question gave you a shear strain here at the surface, you can, because we know at the surface the shear stress is going to be maximum. So if you know that this shear strain and you know G, you can get the shear stress at here, which is the maximum shear stress. Everyone got this one? Alright, let me repeat it again. So, everyone knows this equation?
Yeah.
What is that?
This one is shear strain. This is same as this. Stress is equal to 1 modulus. Yeah, this is shear stress is equal to shear modulus times shear strain.
Okay. That's also the modulus of it.
But
That's also the modulus of it.
yeah. So if you are given with the shear strain at here, you are able to solve for the shear stress at there too. So if the question gave you a strain at the first thing you have to do is find the shear stress. Okay, so after you find the shear stress, you can go here. Because you got this, and usually J is given and C is given. You can get for the torque. That's how the question usually be. Like, ask you to look for the torque. Then with this torque, you can bring it here and look for the angle of twist at here. So just remember to use this equation. Okay, that's basically the main equation for torsion. There is still like a few like power and if you look at this, I read it. There is work, power, and gear ratio. You can go through that, but this is not that important. What?
No, not the that's the ground. Gear ratio. It's not going to be on the list.
It might be, but this is more important compared to this. You just need to go through there is a few equation about work and power. You just need to go through the equation and know the basic of this. But the main thing for chapter 6 is using this angle of twist and the twist in the shot.
Go over like a problem.
Yeah, I agree. So make sure you know everything that I mentioned just now, and we can go through. Okay, so we'll go through this section now. So we spend like 5 minutes and try to solve it with what I told you just now. Do that problem afterwards. That should make that done. Yeah. But I just gotta have to do it. Let's see that. Yeah. good actually. Good, very good. I bet you so we are going to stop this now. Everyone okay? So for the first part, he's asking you for the torque, and he's asking you for the torque, and he gave you the angle of twist is 2. So that's the CL over J3. So you got this, which is 2 degrees, and he's asking you for a torque, so we write it as T, and the length is the whole length of the shaft, which is equal to 1.5. And J, we will calculate this, and G is given the pressure, which is 77 times 10 power of 9. Because I changed this to PA, this G is giga, which is power of 9. And for the J is equal to pi D4 over D4. So the first D is equal to 60 millimeter. In here I change it to meter, and the small d is equal to 40 millimeter. So I just plug this in and I can get a J. So with all this I can get a T here. Okay. And this is for the part A. So anyone have a question on this one? No? Okay, this is pretty simple. So let's go for the part B. So now the question is asking you for, this is the shaft, and he's telling you that the shearing stress at here, I mean in the inner part here, is going to be 70 MPa. So we know that the shear stress at here is equal to 70 MPa. I will write out the shear equation in 70 MPa. I'll change this to power of 6. So I write this way. And the T, I don't know about the T. The C here is not the outer radius anymore, because he's given you the shear stress at the inner radius. So the C here is going to be the inner radius here. So this will be 20 millimeter. I'll change it to meter, and the J remain the same. So even though you are calculating for here, the J is still the previous J, which is pi outer radius minus inner radius over 32. Because we are still calculating for the same shaft, so we shouldn't change anything for the J, as long as we are doing on the same shaft. So just plug in everything and you can get a torque here. You can get a torque. And with the torque, you can bring into the angle of twist over JG. You got the torque from here, and you got everything else, you can get a new angle of twist. Yeah.
The 2 J's.
If you don't put in the J, I mean, you bring it to there.
Yeah.
Yeah, you can do that. So, yeah, because the J is the same, so we can cancel it. And what we do that? The shear strain. So he's asking what will be the shear strain up here. Right? So we can now do this again. Shear strain. So,
Get the torque, get the radius, get change.
Yeah, you got R, you got a radius and a J. This is the outer radius because you are looking for the shear stress at the outer part, which is 30 millimeter. The C here is 60 divided by 2 millimeter. Because you are looking at the outer part shear stress, and you get the new shear stress and using stress is equal to G strain. You can get a shear strain at the outer part. Okay. So, any question on here? So, in the solution, he gave you that. In the solution, he gave you like this shear outer over shear is equal to the outer radius over inner radius. So how did it get this? This is just like, let's say, y is equal to T1, C1, and so here the torque is going to be the same because there is only one torque there. So T and J is the same one, and we can write it like this. T over J is equal to torque 1 over C1. That is, we arrange this, and we can get that torque 2 over C2. So you can use this to get the outer shear stress. But if you are confused, you can just use the original equation and get the shear stress there. Okay. Yeah. So that's for this question. We're looking for the question 14. Okay. So we'll be looking for this question now. Okay. Now we gave you the shear strain at the surface. So what I did just now that we use this equation, you can get a shear stress. And you should be able to solve it.
This one is about 25 right? And then T like first one, right? T.
Yeah, this one. Perfect.
Okay. Yep.
I guess we will start solving it. I guess we are running out of time. Okay. So now here's the question. And the first part is asking you for the torque. And you can see here's a torque T, and there's a T/2 at here. And he gave you the shear strain on the surface of S2. So you know at here the shear strain at here the surface is going to be. And using this equation, you can find the shear stress on bar. Let's call this bar 2. On bar 2, right? So you got the G, you got the shear strain, so you can look for the shear stress at here, right?
Find the shear stress at 2. And then you just find J2 and C2 and find torque.
Yeah, that's right. So after you get the shear 2, you just need to write this equation.
So but J2 is it change in diameter or is it just 1.8 before?
Just 1.8 because this is a solid shaft. This is not a.
Oh, that's just 1.8.
Yeah.
That's not change.
So the J here is going to be 9d4 over 32, where the D here is equal to 1.8 inch. So because this is a solid shaft and this is a solid shaft, so you just need to put in this equation and put in the D here. So with the J, with the C is the outer radius, which is 1.8 inch over 2. Remember, C is the radius, it's not a diameter. Okay. And you've got a shear strength that we calculated just now. Yeah.
What was C? Just C is 1.8, right?
No, C is 0.9.
Oh, so
Yeah, because C is the radius.
okay.
Okay, so you can get a torque. The torque at react on this part. So, but this T is the torque that reacts to this part, to the shaft 2. And you don't know what is the real torque that reacts on shaft 2. So we need to do the cut. So let's work this way. Here is the T over 2. Okay, this is just a 2D version of that question. So always try to draw it in 2D so that you can cut it more easily.
What sort of that the reaction?
Yeah, there is a torque here, but you can draw it up like
That's how I draw it.
TR. So we can write TR plus T over 2 minus T is equal to 0. So TR is equal to T minus T over 2, which is T over 2. Okay. There is a reaction torque at here because there is a wall here, which will try to turn back when there is a torque at the other. So we'll cut here. This is part 2, this is part 1. And for the first part, I will look at it this way. So this part is just this part. So when you're drawing this, always go to an outward direction. This is T1, and this is T over 2. And we can write negative T1 plus T over 2 is equal to 0, and T1 is equal to 0 over 2. And the second cut, we can draw it like this way. Which here is CR, and this is T2. CR plus T2 is equal to 0, and T2 is equal to negative CR. Again, CR, where TR is equal to T over 2. So we can get T1 and T2. Now we can know what is the real torque that react in each shaft. So we can go back to the previous one. At here, just now we got all this equation and we calculated torque, which is the unit torque of this part, which you get is T2. And we know T2 is T over 2, so we just bring it T over 2 into here.
Oh, you go back to that here for a minute? So, say TR equals negative T2.
No, TR is equal to T2, T over 2.
So, for the next one, instead T2 plus TR.
Yeah, so it's equal to minus T over 2. The sign here is different to what is the solution there. Yeah. In the solution there, this is negative and that is positive, but I do this according to what the professor said, so I think it should be okay. You have to ask him before. Okay, so everyone got this? T1 and T2 is equal to T over 2, is just a sign difference. So we can go back to the previous one, and we can plug in the T there. equal to T3 over J, where this is T2, right? Because we got a shear stress at R2, we got a radius, we got a J, and so now we can plug in T2, which T2 is equal to negative T over 2. Now we can get what T is, which is the first question. So the next, everyone okay up here?
Not really.
Okay, yeah.
So what do you do if you find the shear stress using that substitution T2 equals minus T over 2?
Okay, let's start here again.
I mean, how do you find the angle of twist of this?
Oh, we haven't started the angle of twist. We're just looking for the first part.
Oh, the first part. Okay.
Yeah. So you're okay with first part?
Yeah.
Oh, okay. So we go to the next part, part B. The part B is looking for the angle of twist at A. Which A is this part? So the angle of twist at here is just basically the angle of twist of the shaft Q plus the angle of twist of shaft 1. Okay, so first we just need to write angle of twist at A is equal to angle of twist of shaft 2. That's part 2 and angle of twist of shaft 1. Or you can write it this way, of B from C to A to B, from A to B. It's the same thing, it's just the angle of twist of this part plus the angle of twist of this part. Okay, so for this one, we'll put TL over JG, and this one we'll put TL over JG. Okay, so you got an L. The first L is equal to, the both L are the same, it's equal to 10 inch. And the J we calculated just now, right? But the J is different for both. For
G is the same.
yeah, G is the same. For the J of this is equal to pi pi 1.8 or divided by 32, where this is pi 1.5 or divided by 32. Just plug in the J for the part that you are calculating for. And then G is the same at this point because they got the same material here, 4,000 psi. So for shaft BC, which is this shaft, what is the torque? What is the T?
For shaft, which one?
Shaft BC.
T1. Okay. Negative 2.
Okay, so the shaft BC is this one. So which is TQ is negative T over 2. And the shaft, the T at here of shaft AB is equal to positive T over 2. So don't get confused by putting a T using the torque here or T over 2 here. You have to put in the T here is the inner torque of the shaft. It's not those outer torques. Right? Don't get confused by this. Everyone got what I'm saying this one? Okay. So by this you can calculate the angle of twist up here. And now he's asking you for the shear stress on the surface of here. So you just need to, okay, so we just bring in a shear stress equation. Shear stress is equal to TC over J, where C here is 0.75 inch. It's 1.5 divided by 2 is 0.75. And J, we calculate here, J at T. T is the T1 that we calculated just now, which is equal to T over 2. So everyone okay with this one? Okay, so we'll go through the last question before. Okay. Yeah. So we'll go through this one. We just go through it. just think for like 1 or 2 minutes, like how you solve this question. So let's start for this question. So here there is 2 different shells. Here is the aluminum and here is the brass. Yeah. So you got 2 different G at here. You got G aluminum and G brass. So he is asking you for the maximum shear strength at this part and this part. So the first thing you need to do is to do the cut to see what is the inner torque. Because you are given a torque at here, which is 12.5. So let's draw it this way. So there is and this is so here the 2 ends stick to the wall. So here will be a TR1 and here will be a TR2. Because the reaction torque. Because both parts are stick to the wall, so both parts have the reaction torque. So if the question is like this, there is only 1 reaction torque because this part is not stick to anything. There is no reaction torque actually on the shaft. So now you can do it like TR2 plus TR1, TR2 minus TR1. Minus 12.5 is equal to 0. And you can do it this way, or you can do it, or you can just cut it here. There we go. You can cut it at both sides, so you can see. That's what this is C over there. And this is
So which part are you at?
I'm cutting at both sides.
The same time?
Yeah, you can do it this way, or you can do it like, you can do it by, okay, let's go skip a step. Okay. Just ignore this. We are going to do it as this is just like a faster way of doing it. Okay, let's do it this way.
Yeah.
Okay. So let's say this is C aluminum, and you can write out C aluminum is equal to negative PR2. And the second cut is here, and here is PR1. And here is T breast. I write TB for T breast. So T breast is equal to negative PR1. And you know that TR1, and we got a previous equation that TR2 minus TR1 is equal to 12.5. So you got this relation, and do it for
Plug it to TL.
what?
Plug in TL and TV.
PR and TB.
Yeah.
And how do you do it? So, you know, two of these are attached to the wall, right? So the total of the angle of twist is equal to 0. Ever got this? Like, let's say if this is a question, the angle of twist at this part is equal to 0 because it's attached to the wall. You cannot turn it here. The part that would twist is at here, the whole shaft, but not at this point. So at this point, the angle of twist is equal to 0, and at this point it's equal to 0 too. So if you add on the whole angle of twist, it's going to be 0. Okay. So you can write it, the equation. And with this equation, you can get the relation between TR1 and TR2. So it's the same like you got two unknown, which is TR1 and TR2, and you got two equations. Here you can put it TL over JG, and here also TL over JG. So for shaft BA, is equal to, the T is equal to TR2. For shaft CB, the T is equal to TR1. And then R is even, J is even, T is even. You can get a relation between TR1 and TR2. And you got another equation that we got it just now. So
And then you could just plug in 12.5
yeah.
plus TR1 equals TR2.
Yeah, and then you can solve it. So this is basically all the same type of question. You just need to find a relation and solve the two unknowns. Okay. So I think that's it for today. So, if you have any question, yeah.
What was your first test?
I got it. 23 out of 30.
Yeah, 30 minutes, but
Yeah. Played it a lot.
Yeah.
points in the whole semester.
Wait.
Yeah, 30.
I didn't see that.
Well, is it?
I bet you we get pretty much. Watch me get out there and, like, you know, say, come up with the damage, just show you.
This TR2 you want to push the
I know, I wish everybody would get a good day. I want to get a good day. Well, they kicked up
but the solution is also
Wait, so I get it for the final version.
I need to find it. I don't suppose to get it. I get it. My grade is still like 90.
So, you got your 10 minutes. You got your 10 minutes. And one was
starting from here, this part is seen as usually if you're looking for the angle yeah, you're right. It's not very turning, so at here starting out
oh, mas não, você vai ver aqui, aí tá aqui, ó, só uma dessas, não fica mais uma. Another situation, instead of doing two cuts, I can do just one and then analyze it. Like, can I cut just before and after the first and analyze everything?
yeah, you can do it, but it's a bit confused.
I think that's confused me.
That's confused. You can do that.
But when I cut the first thing, like always going out or going out.
So you can do two cuts at the same time. Sorry, how do you?
Yes. It's really easier. And then that's the first one, first two.
Yeah, you can. You can
Edit the arch.
Someone's still.
Edit the bars.
You did it?
If I want to analyze that, and then I can do this, and then there's another video, and then do that, and like this, and then analyze like by one and by two.
Yeah, you can do the both.
And then I analyze by two and by three at the same time. Like two double cuts.
I think you can do it this way, but this side is going to be changed. And you cannot forget, like, if there is a reaction point or two. But if there is so many bars, I want to do it this way. It's confusing to me, but I'm not sure. If you're used to do it this way, you can do it this way. I haven't tried to. Yeah, I'm not sure because I'm not doing it this way, so I cannot.
But why it was red?
I don't know, it's like maybe different sensor or
Yeah, reaction.
You said about that, or that's into the.
They say that.
Caralho, quero fazer isso.
yeah.
Their way of doing it, so on this side, I had to.
Eu sei, eu vou aqui. Essa vermelha.
That way I.
Logo, velho. Eu quero a quadrada.
The first thing you need to do is like you see like how much you can expect, right? So you will expect more than you get.
Yeah, I know. You check the change temperature. And I did, and it says capable of yeah, just the thing is, like, the reaction that way, and I did it to the F2 minus R, because you have to keep it on. And then I get R is equal to F, which is equal to and then they get the because they did equal, which is really stupid. So the same for here, like well, F where? Well, F would be
you are looking at this way, right? You always have to integrate all of them. You can integrate this way.
oh,
So the relation is F equals
okay.
so I think
You always have to. So same with, so here, how did they do it here? Like, how do you find the reaction force? Because I know how to do it in a second, but
yeah. So like here, so you would expect it going up well, how do you do it? First part of so F1
okay, that's at F1, but is the force at F1 equal to the force here at F? It is. So the force here is going to equal the force here.
but you can cut it like this way, but here I didn't do so I just do it this way.
Alright.
And one thing you mentioned, you didn't have this.
I had class.
Oh, okay, here's a different version. So at this, here's really like the total like the elongation of the normal plus the elongation of stress equal to yeah, right?
Yeah, but that's for one.
Yeah. So let's say the stress is equal to FL.
Yeah.
The L is equal to the L of the original length. Yeah. So the L is equal to the original length. This, I show someone that it's
L, what about what was the L be here? Is it the whole thing or is it just one half?
just one half. Because you are completely yeah, you're agreeing for this part and this completely for that part, and then you're agreeing for this part. Okay. Yes, they got a different half. Yeah. Okay. Right.
You don't understand. I mean, you understand like this, like these diagrams?
Oh, this, I don't think it's going to be also.
No, it's not. It's just that I wondered, finding distance with this x-axis. And like S and
the point that
yeah, so here, I understand how to solve for and it's like doing a change in the of the x it's W, and that's just not but that's just here, curve, I have 25 down there, this is the
I will revise.
now, yeah, I thought you said it's not,
Try to review, revise this and review next week. If there is no review, that's not what it is.
okay, that's fine.